Today's lesson is on relations. I want you to try to think of variables, two different variables that relate to each other. As you can see, I'm running next to Usain Bolt. Think about how his distance and time relate to each other. Two different variables that together create a relation. The mathematical definition of a relation is simply a set of ordered pairs relating x and y. You've often seen it like this. X and y, they can be represented in an equation, a graph, a table, mapping diagram, or just a set of points. Here is a picture of the coordinate system, which is often used to graph relations. A coordinate system is the intersection of two number lines. One number line represents the vertical axis or the y-axis, and then the other number line would represent the horizontal axis or the x-axis. And then here is just a point, which we call an ordered pair, x and y. And then I've also used the words domain and range, which we will learn more about later, but domain coordinates with x and range coordinates with y. And then here, where they intersect, that's called the origin, the intersection of the two axes, which is the point 0, 0. Here we have a set of ordered pairs that represents a relation, and we're going to use that same set of ordered pairs, and we're going to properly show how they are expressed in a table, an XY table, in a mapping diagram, and then on a graph. So let's start with a table. Sometimes these are called T-charts, or I just call them XY table. So generally, your X values will be listed smallest to largest. So X values are always the first number. So let's find all of these and list them smallest to largest. And now you can list the Y values next to the corresponding X values. So negative 9, 0. So negative 9, 0. Negative 4 matches up with 5. Negative 3 matches up with negative 2. And then 7 matches up with 4. So here we have an XY table that shows this relation, this set of ordered pairs. Here we have the same set of ordered pairs, the same relation, but instead of an XY table, we're going to create a mapping diagram. A mapping diagram consists of two ovals that separates the X values and the Y values. And in both oval, you will write all of your X values smallest to largest and all of your Y values smallest to largest. So they will not correspond next to each other like they did in the XY table. So here are all of my X and my Y values listed smallest to largest, and then I need to show their correspondence with arrows. So my first point, negative 4, 5. Negative 4 matches with 5. Negative 3, negative 2. Negative 3 matches with negative 2. 7, 4. 7 matches with 4. And negative 9, 0. Negative 9 matches with 0. So there's my mapping diagram. Now the last way to represent this set of ordered pairs would be to put them on a graph. So we just have to graph the points. Remember, we have the x-axis and the y-axis, and every ordered pair is x and y. So negative 4 tells you to go negative 4 on the x-axis, and then 5 on the y. 1, 2, 3, 4, 5. Here I have 1 dot. Negative 3 on the x, negative 2 down. Right 7 up 4. And then negative 9, left 9, up 0. So we have these 4 separate dots. We do not connect them because it does not represent a continuous constant equation. it is simply 4 separate points relating x and y. So it's just, we leave it at 4 separate points. Here we have a real-life example of a relation. It's relating two variables, time and speed. We're comparing how the meters per second changes over time. So, down below I have all of these descriptors that I will place on the parts of the graph that it represents. If you look here, from 0 seconds to about 5 seconds, the speed is increasing. But then between 5 seconds and 10 seconds, the speed doesn't change. It is staying at 10 meters per second. So we call that the speed is constant. It's not changing. And then from 10 seconds to 13 seconds, the speed is decreasing. And then from 13 seconds to 16 seconds, it's all the way at 0. So there is no speed. You could think of that as being at rest. And then it goes back to the speed is increasing. And then when it's flat, the speed is constant. It's not changing. So here I have analyzed the relation between time and speed and have described every part that the graph changes. So here's your lesson on relations. I want you to think about your daily life and think about what things you do that involve two variables working and changing together. Maybe one thing depends on the other. Let me know what you come up with.